My name is Daniel. Welcome to our YouTube channel. And today we are back at you guys with another video. Alright, so let's get started. Today we will show you a new prototype of a permanent magnet motor. And then we will compare both of them. We won't talk too much about this magnet motor. We made a separate video for this one. If you want to watch it, click the icon in the top right corner. This motor has two rotors. Each rotor has 8 2-inch magnets. It has 7 electromagnets. The smaller coils are for the timing. The timing wheel can be adjusted. This motor has aluminum shafts, stainless steel bearings, and brass screws and nuts and bolts. Here we left some space for additional electromagnets that will be used as generating coils. This motor will be a motor and a generator at the same time. Also, a windmill can rotate the shaft of the motor to generate electricity through this pulley. We will show you the principle of operation. We will connect a battery to an electromagnet for only a second, and you will see the permanent magnet jump 5 feet in the air. First we will try the smaller electromagnet, then we will try the bigger one. In order to have a successful magnet motor, there are several important features you need to include into your design. Feature number 1, electromagnets pancaked by 2 rotors with permanent magnets provide more torque to the shaft with the same current input. We will demonstrate that with this experiment. Here we have a metal plate with a 1/2 inch permanent magnet on it. We got 2 clamps holding the metal plate at the bottom. Here we have a 1/2 inch iron core. We will use a scale to measure the strength of separation. Now we pancake the iron core with 2 permanent magnets, and we will compare the force. When there is only one magnet, there's little interaction between the magnet and the electromagnet. But when there's 2 magnets, one on each side, one facing north and one facing south, there's twice as more interaction between the coil and each magnet. The magnetic field is more focused. Here we have a coil of 5,000 turns of wire. And here we have 2 LEDs. Also, we have a permanent magnet. We will attempt to induce electricity. There is very little interaction. Look what happens when the coil is pancaked by 2 permanent magnets. Now we will do it in the dark. Feature number 2. When using Befilier wound coils, you can have a stronger electromagnet with the same power input. Also, when using the collapsing field energy, it can store double the amount of energy. Also, if the coil is used as a generating coil, it produces twice the voltage with the same mass of wire. of a failure wound coil is made by two wires side by side wound into a coil. You connect one of the starting wires of one coil with the ending wire of the second coil. The other two wires will be one positive and one negative. Energy is stored between the two coils. Feature number 3. When constructing a magnet motor, you have to eliminate all iron from the motor by using non-magnetic materials, except that of the iron core. This permanent magnet can affect the needle of a compass from 4 feet away. Also, you will need a high-frequency iron core. Feature number 4. The efficiency of the motor goes up by adding a greater number of magnets and coils on the same rotor. As the rotor doubles the speed, the energy input drops by half. This rotor has 4 magnets. This rotor has 6 magnets. And this rotor has 8 magnets. Feature number 5. An uneven number of magnets and coils increases the efficiency of the motor by running smoothly and using less energy. The rotor can rotate with very little force. This motor will run on one 12-volt battery for 1 hour. It uses 70 watts of electrical energy. We will turn on the motor and watch the voltmeter. The voltage will begin to drop slowly. This motor has 7 coils. We will use 5 coils on the motor to rotate the shaft, and the other 2 as generators to charge the battery. Here we have a rectifier to convert AC to DC. Watch the meter. At first the voltage will begin to drop, then slow down, then stop, and slowly go back up. This motor has inductive energy, collapsing field energy, and mechanical energy. We have 4 loads, 1 inductive load and 3 resistive loads. Some will be powered by inductive energy and some by collapsing field energy. This prototype is twice as efficient as this motor. Thanks for watching, everyone, and make sure to subscribe because we have some really cool videos coming your way. And I hope you enjoyed this video, and if you did, make sure to hit that like button, and we'll see you next time.